Welcome to the Math Record. Today we'll be covering logistic functions. This video will be part 5 of chapter 3 in our Precalculus class. In this video, we will introduce the concept of logistics and cover its properties. So, what is a logistic function? Well, it's basically an exponential function that has a limit. So, remember from the previous 2 videos where it said a exponential has something looks like this? Well, now basically a logistic function is similar to that, except it doesn't have this negative portion. It goes something like this, similar, and then it goes back around. So it goes something like this. So there's this line which it has a limit at, while a exponential function has no limits. So anyways, let's cover its properties now. The logistic model is in the form y is equal to c 1 plus a e to the power of negative bx. So let's talk about the basic properties, which is domain and range. Since I said the graph of the logistic looks something like this, its domain would just be from its y-intercept to like infinity. So so the y-intercept starts at x is equal to 0. So the domain would technically just be from 0 to infinity. And its range, since we already has this domain, which is 0 to infinity, we could just plug that in. So 0 into this equation would just be negative b times 0 is 0. So e to the power of 0 is just 1. So c over 1 plus a is just c over 1 plus a. So then the range starts at c over 1 plus a. And the next value is infinity. So as x becomes a really large number, this becomes a really large negative number. So e would just be 1 over e to the bx, which is the same thing as this, just this portion right here. Right here. So once you put a really large positive right here, that means this number is going to get super small. So if this number gets super small, multiplied by this number, that means this number overall would just be super small. So it'll be over to 0. So this guy gets like to up like really close to 0, and it'll just be 1. So it's just c divided by 1. So it's just c. So that would be our limit, but it's never gonna approach c because as this approaches really small, it still has some numbers. It's gonna be like this, or like it's gonna get really, 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 really small. But it's always gonna be a like less than c, but it's gonna get really close. So the next property that we are gonna talk about is intercepts. Let me delete a part of this first. Alright. Delete. Zoom back in. Okay. So let's talk about its intercepts. It only has one intercept, and it's only the y-intercept, because remember for our picture, the graph looks something like this, right? There is no x-intercepts. It's usually never gonna cross this. There's a y-intercept though, which is the first point. So the y-intercept is just where it started when x is equal to 0. So the y-intercept is just c over 1 plus a. That's what the y-intercept is. And for asymptotes, there is only one asymptote. It's the horizontal asymptote, because as you see in the graph, it kind of like gets around to this point right here. So the horizontal asymptote is right here. So we need to find that value. So as this approaches a really big number, this would be the other part of our range. So remember our range was c over 1 plus a to c. Well, this is gonna be our y-intercept, and c would be our horizontal asymptote at y is equal to c. Because if you think about it, as this number approaches a really big like x value, a really big large number, then this number gets really small. then c over 1 plus a really small number is just c over 1. So it's just c. So this approaches y is equal to c at this horizontal asymptote. It would never cross this. What this horizontal asymptote, what c is referred to as is the carrying capacity. Because it cannot go over these this number. Because what this number usually, what this model usually, a logistic model usually covers is populations. Because a population, what the news usually say is that it's increasing exponentially. But since the Earth has limited resources, we usually it's usually believed that that it's not gonna be exponential, because right now we're gonna have like an exponential curve because we don't have enough time, like we didn't cover enough years. But sooner or later we're gonna go to this curve like a logistic, because there's not enough resources to like sustain everyone, basically. So while let's say like the Earth can only like has enough resources for like I don't know, like 100 trillion people. I mean, like yeah, 100 trillion. I don't know the exact number after trillion. So after 100 trillion people, you have that's like how much people you can have. So you can't have over that number. I don't know what's the specific carrying capacity. You can look that up on Google. And there's also one more property which is called an inflection point. We would not be inflection points could be covered in polynomials and also in rationals, and it could also be covered in like more types of graphs. But in just we're just gonna only focus on inflection points for our logistic functions for this class, because for polynomials and for rationals, rationals is more difficult and it's not as useful. And also, for polynomials, inflection points will be covered in our future calculus class. So when those are released, you can look at there. But for just in this case, for our precalculus class, we're gonna only learn inflection points for logistics. A logistic inflection point is when the point is changing concavity. So what does that mean though? So basically, let's look at a graph like this, right? We have a cubic function. We have something that looks like it's that's concave down, right? But it looks like it's concave up too, right? So what you do, an inflection point, it's basically a point in the graph, like let's say it's right here, is where it changes concavity. So it changes from concave down to concave up. So we have to look for an inflection point. So basically, if you just look at this graph, there is a graph like right here, concave up, and then it looks right here, which just looks like it's concave down. So you gotta look for this point. This point is usually halfway between the the y value, which is basically is halfway of the carrying capacity. So what it usually says is that let's give an example. Delete. Okay, let's say we have y is equal to 300 all over 1 plus 2e to the, sorry, e to the negative 0.1x. So the carrying capacity would be 300, right? So our inflection point would be at y is equal to 150, because it's halfway of the carrying capacity. So the inflection would be at 150. So if y is equal to 150 is equal to 300 over 1 plus 2e to the negative 0.1x, that means it will be 2 is equal to 1 plus 2e minus 0.1x. So we have to find out when this is equal to negative 0.1x, right? Now, if you look at this graph, if you look at this equation, basically, we just need to find this x, which, as you remember, like 2 videos ago, I mean 1 and 2 videos ago, this has to be like a exponential logistic question. So what you do is that since this is e, you use natural log, which is represented by ln. So you got ln of 1/2 is equal to negative 0.1x. And then you just divide by negative 0.1x from both sides just to get x. So using your calculator, you put ln of 1/2 divided by negative 0.1 is x is about 6.9. So that's when it's so x equals 6.9. About 6.9 is gonna be our inflection point. Is where it's gonna be. All right. Anyways, that covers everything about logistic functions, or what we need you to know for this class. Thanks for watching, and I'll see you at the next math record.